morning, everyone. My name is actually Adam Thomas. Dan had to be out for the day. I'm head of MPI and marketing at Arcanum Alloys and a member of the founding team. At Arcanum, we don't make the steel you use, we make the steel you use better. We also don't make original slogans, so I apologize if the BASF in the room. Come find me afterwards and I'll apologize in person. What we do make is we make steel. Steel, if you can imagine the weight of all the water in all of San Francisco Bay, the steel industry makes that much weight of steel every 5 years. That is just an enormous scale. And to do that, they have had to compete with one another and to take that amount of rock and dirt and turn it into molten steel, and then turn that into slabs, and then cast, and then roll, and then coat it into their final forms that are then useful. To do that, they've had to standardize a lot of things and have kind of funneled themselves into a fairly narrow process. That narrow process, unfortunately, makes a product that is flawed. If you take a look at the rectangle at my left and right, the red dots represent the alloying elements in a traditional sheet of steel. That's a cross-section, if you will. They're homogeneous. This has been traditionally the hallmark of a highly refined process for 170 years. If you didn't have that, you'd get poor performance, and so they've strived to make that. Unfortunately, that forces trade-offs, and those trade-offs are the real problem that Arcanum solves. Trade-offs for corrosion resistance would be lower formability. The trade-offs for electrical steels would be higher or lower power or higher efficiency. Strength of steel, all sorts of different properties are traded off via this process. Arcanum's solution is to spatially optimize where you put those alloy elements. In the case of the stainless products, we're able to put the chromium, which is the corrosion-resistant alloying element on the surface, leaving the core carbon-free, alloy-free, which makes it the whole thing extremely drawable and formable. Now, instead of using only carbon steel products in certain assets, OEMs are able to use a stainless product, and therefore the value of that asset has increased substantially. In the case of electrical steels, typically they put silicon inside the steel, and that silicon does decrease power, but increases the efficiency of electric motors. In our case, we take the silicon and put it only on the surface. Now you're able to get higher efficiency, even higher than those offered by the highest silicon steel content containing steels today. And then also you don't trade off that power. So you can see that the value here is pretty great because of the ubiquity of these materials. So how do we do it? Well, like I said, we don't make the steel. We basically have taken some semiconductor science and inserted it towards the end of this process. Switch up the last two here, annealing and coating, and insert that technology, as I just said, ABC becomes CBA, or ACB, and there we go. So these red elements here, these are what we can put into the steel. Basically all metallurgically important ones. Not everything, but the stuff that you need. To do that, we've taken chemical vapor deposition technology and inserted it into the roll coating process and the annealing process, and we can alloy these into steels. That said, this isn't just about steel. This can be aluminum, this can be copper, this can be nickel, other things that come in coils. All that works. And it's not just coils, it can be parts too. We demonstrated this on pistons for shocks, we demonstrated on wire. So anything where there's a value proposition to be had from changing the functionality of the material, that's where we want to operate. We've only identified a few markets that we're really interested in, and these already offer plenty of low-hanging fruit for us. So, obviously we can't do this if we can't produce at scale, given the size of the industry, and we are doing that. We have taken stuff out of the lab and have now inserted it into making 40,000 pound coils of steel. We can do 2 a pop, and really the only limit to the scale here is getting more of these annealing bases, which are take about 6 months to do, so that's your capacity limit. Products we make are in everyday appliances, they're in automotive components, and also building elements. So the resistance welded tubing that goes into fire suppression system piping. I know it's not crypto or iPhones, but it's still pretty useful stuff. So key takeaway, we're a really small team, very nimble, very effective. We've developed a new class of highly engineered materials that offer outsized performance to the customer. We've scaled that material, and we have significant intellectual property to protect our materials and processes. Customers are currently paying about a 30% premium for improved performance on the stainless products. The electrical steels are still in development, and those offer even more potential for margin. Our production partnership is with an integrated mill in North America. Can't say who that is yet. I'm still working on some final details with the government to give them some funding based off of innovation. And we plan to reach cash flow break even by the end of 2019. And right now, the reason why we're here is not necessarily just to raise money. We are trying to do that to expand the team, purchase some assets, but also to just make companies aware, companies like yourselves, that we do exist and can satisfy a multitude of needs you might have. So thank you very much for your time. I'll leave you with the leadership team. And there you go, leadership team and our advisors.